Hello friends, welcome to my channel. So in this project, we will be learning the SMS map filtering using the Naïve Bayes algorithm. So Naïve Bayes is a probabilistic machine learning algorithm, which means it predicts based on the probability of an object. And it uses the Bayes theorem, which is widely used for classification tasks. And it's mainly used in text classification. So Naïve Bayes. And so one important thing is, in spite of many advanced ML algorithm, Naive Bayes classifier is one of the simple and most effective classification algorithm, which helps in building fast machine learning models and that can make quick predictions. So Naive Bayes actually assuming all the filters are independent or unrelated. That's what it's called naive, and it cannot learn the relationship between the features. So that's one of the caveat for this naive Bayes. So let's get started with this project. So we will follow these steps while building this project. So first we will import and pre-process the data, and then we will vectorize the sentence. So we will convert the sentence in the data into vectorize. And by the way, we will be downloading the data from the UCI machine learning repository. So special thanks to the UCI Urban students who is maintaining this repository and have huge data set. So we'll be downloading it from there, and I'll paste the link of the repository in the description box. Please go and download from there while working on this project. So yeah, second we will vectorize the sentence. Basically the bag of words representation. We will put all the um, all the vocabulary that is in the sentence in the bag, and then just get the count that I'll explain when we'll go through it, and then we'll train the model and predict the result, and then we will test the accuracy of the result using the confusion matrix, and we'll go with specificity and sensitivity, precision, recall, F1 score. We'll calculate a lot of things, and then we'll visualize the test result also using the ROC curve and also area under the curve. And in the end, we will get some sample text to see what the prediction is happening while passing those input to the model. So let's start with the first step. So I'll be using the Google Colab for this project. What I have already done is I have uploaded the file that I have downloaded from the UCI ML repository. So I have uploaded that here. So it's basically in the recent sessions. When the session is gone, then session is disconnected, then this file won't be available. So you have to make sure that you upload this again in the file session. Or basically you can upload that into your drive and then get it from the drive using the G drive library. That also can be followed. So let's start. So what I'm doing is I'm importing the pandas library, our important library for reading the table. So I have given the alias as PD, and then I'm using the pandas read table to read the table, the spam collection that's over here, and then the name of the classes is class and then SMS. So let's run this. So now it's so now we using the pandas head methods. What I'm doing is I converted that into the data frame. So now you can see the classes spam, ham, and SMS. Like these are the SMS. So each of the row is having one SMS with different words in this. So if we look carefully in this, what Naïve Bayes is doing is it reads each of these words. So if you look at spam, it's free, and then you can see like these words like free and then win, like these words. The Naïve Bayes actually calculate the probability, and based on that, it make the decision whether it's a spam or ham. So that's why these words are being converted into smaller words and then put it into the bag of words that we will see later. So this gives you some idea that how Naïve Bayes is calculating that whether it's a spam or fam by reading these words. So now let's look at the length of the document. So it contains 5572 SMSs. So let's check the value counts also. It is important to see how the class balancing is. So based on that, we see that ham is 4825 and spam is 787. Let's get the percentage, like how much percentage the spam is. So if you look at the percentage, so it's around 13%. So 13%, like it's not a big number, like but not a smaller number also. Like if that is less than 5%, then we can say the class is really imbalanced. But here we can say it's a decent number. That 13% will still help the model to detect, to learn from the sentences and make the prediction. So what we can do, what we are doing again here is, as the naive Bayes, like we are using the scikit-learn. So scikit-learn use the depend on the numbers. So we have to convert these spam or ham into zeros and ones. So what we are doing is I'm just mapping it, the ham to zero, so that we have to remember when it is zero, then it's a ham, and when it is one, then it's a spam. So I'm just mapping it. So let's run this and giving the label, creating another column as label. So now if we look at the head now, so we have another column as label. So ham is all zeros and spam is one, and we are detecting the spams here. So now let's drop this as a redundant column. So we can drop this using the drop method of data frame. So we are giving access one because we need to drop the column. So now that is gone. So now let's move ahead and convert this x and y, split the data into x and y, so so that we can use it for training. So what we have done is we have converted the x and y for our training and test set, and so the SMS is stored at an x, and the labels are stored as y. So let's look at the shape of these. So both are now converted to the numpy. So now we can pass this numpy into our scikit-learn. So before that, let's split that into a test and train set using the scikit-learn model selection, and we will import the train test. So and then what we are doing here is we are calling this train test split and passing this x and y. So what it will do is it will split the x into x train and x test, and the y into y train and y test, and we are giving the random state as 1, so that it when it runs multiple times, we will get the same numbers. And also I think the default number is 7525, so that's the way it will be splitting the test and train set. So let's run this. Okay, now let's look at the x train head. Okay, so now it only contains the SMS in the x train, and let's look at the y train. So Y train only contains the zeros and one, whether it's a spam or ham. Okay, so now let's move on to the vectorizing the sentence. That's the second step. So what we are doing here is we are extracting the features from the sentences. So if I go back and look at the head, so what we are doing here is for each of the SMS in this row, so we are taking out these words and counting how many times these words exist in this document. So that's what is the count vectorizer. So we are doing it using the scikit-learn count vectorizer. So that is the vectorization of the sentence. And we are removing the stop words. So the count vectorizer already have this inbuilt. So if you have stop words at English, so what it is doing is there are a lot of stop words like the, their, so is, so all these are actually redundant and doesn't have any features. So what we are doing here, we are just removing those and only keeping the words those are meaningful for the model. So that way we go to each of these sentences one by one and only pick the one that is meaningful and remove the stop words. So that's what we are doing here, and we are storing that in this vect instance. So let's run this, and now we are fitting that the x train. So now the instance is created, so we are passing the x train to this count vectorizer. So let's run this. So now it created the count vectorizer, and let's look at the vocabulary here using the vocab So now you see like there are different words. So these are just the indices of these words that exist in our document. So what it is doing here is, so if I go up a little bit, so if I look at the head, so if the go exists, so what it has is like, okay, it's look at the go word and look at which all document this go word exists, and then if it exists, let's say at the 0 document, so this will have one value, and then if it doesn't exist, this will have zero value, zero value, zero value. So it stored a lot of information that is not important for the model, because rest of the document it will just have a zero value. And uh, if let's say until exists in document 1 0 and 1, then it will have these two document as one value, and rest it will have zero value. So that's what it is doing here. So it has a lot of redundant information. So let's look at the so it's basically a dictionary, so you can use the key. So it has 7204. So we need to actually transform this redundant information into a sparse matrix. So what the sparse matrix is, it take out all the zeros and only keep the one in the document, the meaningful information. So that's what we use using the transform matrix, and then pass the xtrain and the xtest. So we don't need to fit on the test data. We just need to train on the test data and then transform the train data and transform the test data, but don't need to fit on the test data. So let's run this. So now we have now removed all the zeros and then created a sparse matrix. So let's look at the sparse matrix, how it looks like. So now it is converted into the sparse matrix. And if you read it, so what it is saying is at document 0 and the 50th indices, so it exists at 1, document 0 to 64, it exists 2, and the document 4174 at this location it exists. So this is basically the features. So it's saying the feature 4417 at document this it exists one time. At document 2 feature 98 it exists one time. So it actually using the count vectorizers, it converted all these vocabulary into the features and converted that into the number, so that we can feed it to the Naïve Bayes model. Okay, so now let's start with building the model, and then later we'll evaluate the model. So we will use the multinomial Naïve Bayes from the scikit-learn. So we have another called binomial Naïve Bayes. So binomial, the difference is like here, instead of calculating like here the Naïve Bayes, the multinomial actually shows that how many times that particular word exists in that specific document. But here the binomial actually just says whether this particular word exists in the document or not. So instead of two, it will be just one. So that's the difference. So we'll be using the multinomial here. So we'll just create an instance of it, and then we'll fit the model on the transform data. So that's our sparse matrix. And then we will pass the white-ren, the actual labels. And then the multinomial has actually two methods. One is predict. So what it is doing is it will predict the class, but it has predict probability also, where it gives the probability as well. So like the way in the logistic regression, the probability, converting the probability to the class depends on threshold. So here it's auto calculate that, but we can get the probability as well. But for now we'll be using the predict. So let's run this and get the prediction using our multinomial Naïve Bayes. Okay, so now it ran it. So now let's evaluate the model. So for the evaluation, there are lots of different types of metrics. So we will start with the accuracy score. So let's see so we'll be using the scikit-learn metrics, and then we will be using the accuracy score. We'll pass the white is the actual the labels and the predicted one from our model. So by predicted class. So after passing these two, it will predict. So our score is 98.77. That's a pretty good score. But actually, we cannot rely on this accuracy score because there are some errors in this. So for classification, there are other metrics that are more important. because there are two types of error in this. The type 1 is basically you can misclassify spam as a regular message, and type 2 error is you can misclassify a regular message as a spam. So it depends on what is the priority for you. So you have to work with your business to understand what works better for them, and based on that you have to say which one you have to look more carefully. So for our use case, we will go with type 2 error, where you cannot misclassify a regular message as a spam, because it can be an important message and you classify as spam, so it will be filtered. So we have to make sure that type 2, there shouldn't be any type 2 error. So in order to do that, we have a classification, actually the confusion matrix. So confusion matrix actually compares the actual target value with the predicted value. So we can use the scikit-learn confusion matrix directly and pass the white list and red crawl. So it creates a table sort of thing. So let me show you. So it created a table. So what it shows is the rows represents the actual value and column represents the predicted value. So this is a actual value. So actual value 0 and 1. So this will be the 0 like when the label is classified as 0, and it's classified as 1, and predicted is what our model predicted. So that is 0, the column wise, and the 1. So when it is, we are saying actual 0 and predicted 0. So that means 1 to 0, 1 is actually predicted by our model as 0. And then when it goes to actual 0 and the predicted is 1, so then actually it's saying that the actual value was 0, but our model predicted 7 as 1. So again, if you go to actual as 1, and this is predicted column wise, predicted as 0, so that means the model inaccurately predicted 10 values as 1. Sorry, as predicted as 0. So this is an actual one. So, but this is a 0. So the model actually wrongly predicted these 10 values as 0. So that means our 0 was, so let's see what our zeros was. So we labeled zeros as non-spam and 1 as spam. So, and then this is the 175. So that means 1 and 1. So that means 175 were actually labeled as spam, the actual value, and our model also predicted as spam. So if we actually take out some important values from this confusion matrix, so true negative, if we see true negative, that means this is 0, this is 0, and true negative is our non-spam. So that means 1201 was the non-spam messages and the model correctly predicted as non-spam. So that is our true negative in the confusion matrix. If we come to confusion matrix 01, so that means the actual as 0 and this is 1. So that is false positive. So that means it was actually labeled as 0, but our model predicted as 1. So that means those were non-spam regular messages, but model predicted as spam to them. So this is an important one for us because we don't want anything to be labeled as spam if it is a regular message. And if we come here at 10, so that is 1. So that means this was a spam, but our model predicted as non-spam. So that means 10 is still we can survive with this, but this we cannot survive. And this is 175 is model predicted as 175 as spam, and it was an actual spam. So that's what the false negative is, this one, when the model is actually predicted them as spam, but it was, because the predicted is 0 is an actual is 10, but it was not actually a spam. So this is false negative. And then this is true positive. That means this was actually spam and the model predicted as spam. Okay, so these we have, we can get it from the confusion matrix. So now the two important metrics that we have to look is sensitivity and specificity. So sensitivity is actually a true positive and specificity is actually a true negative. So sensitivity explains that out of all the actual spam, how many model predicted. So let's see the number here. So let's run, sorry, we have to run this before. So let's calculate this and then let's run the sensitivity. So it's 94%. So what it explains is 94% of the spam were actually correct, actually detected. So the model predicted 94% of spam. So rest actually were not spam, but those were still marked as spam. And then let's look at the specificity is, so let's get the number for this. So it is actually 99%. So what is explained is out of non-spam, how many model actually predicted. So this is the important one that we have to look at it, because those are non-spam, those are the regular messages, and how many model correctly predicted. So this is 99.4%. So that means the model did a pretty good job in actually predicting the non-spam messages, and 94% when it is predicting the spam messages. So it is clear we want a specificity to be high, close to 100%, because I don't want any messages to be tagged as spam if it is a non-spam. It should be fine if some of the messages classified as spam. So that is our sensitivity. So now there are other metrics also, like precision. So precision actually calculate how accurately you are labeling the positive. So there is a difference, like in the sensitivity, it is instead of the false negative, we say true positive plus false positive. So it actually calculate how accurately you are labeling the positive. And let's calculate this as well. So it is coming down to be 96%. So that means 96 out of 100 are actually spam and the rest were not spam. So that's our model is predicting. And similarly, we have recall score, F1 score. There are other metrics which F1 is basically the mean between the recall and the precision. But for our use case, the most important is the specificity. So this also we can say F1 score is 95%. So that is also a pretty decent one. So now let's look at the classes. So as these are already labeled, and the probability also, we can look at it. So these are the numbers it is showing. So last thing to evaluate the model is built-in ROC curve. So ROC curve are used to see how well your classifier can separate the positive and negative values, and to identify the best threshold for separating them. So it takes basically the Y test and the Y probability. So basically it's two-dimensional. So I'm just taking it the all the rows and the column, and then it takes these two parameters and it returns three values: the false positive rate, true positive rate, and the threshold. So basically it draws varying the threshold as you get different the false positive rate and true positive rate. So when you get, so it draws actually the curve when you change the true positive and false positive rate, and try to find the best threshold value. So basically you want the true positive rate. This should be as high as it can be, and but at the same time we want the false positive rate to be low. So basically let's draw that first, and the area under the curve. So that's the second important matrix, is shows how far the curve is from the baseline. So let me draw this first, and let's print the ROC. So basically the area under the curve should be as high as possible. So the baseline is 0.5 and the perfect is actually the 1. So 0.99 is a very good score. So what I'm doing is the ROC curve, I created a data frame so that we can see how it is look like as a number. So this is the true positive rate and false positive rate. So as I am explained, like as we move the threshold, the true positive rate should increase and false positive rate should decrease. So when we are moving the threshold, so how these numbers are moving. So let's visualize that together better understanding. So I'm just using the matplot plot and false positive on the x-axis and true positive on the y-axis. So let's draw that. Okay, so now you can see that as we move the threshold, so this is basically the threshold. So the false positive rate should always remains 0 and the true positive rate should be close to 1. So basically the curve should go like this. So it should be hugging these two axes. And this is a pretty nice and decent curve because as you see the false positive rate is still 0 and the true positive rate is going close to the 1. So the true curve is actually goes like this, and all the area under the curve is actually that calculates that how good the model is. So maximum, if it is 1, then the model is good. So that's basically these are the different matrices that you can use for the classification. So let's do one more thing is let's get a sample input. So what I did is I added a sample input, and let's see how the model predict for this. So first we have to transform them into the sparse matrix. So that's what I'm using the transform. We don't need to fit it. The model is already trained. We just transform into the sparse matrix and using this to predict it. So let's see what it is doing here is. So it's returning array 1. So as I explained, the 0 is labeled as non-spam, the regular message, and 1 is as the spam. So it detected it correctly. It's a spam. So now let's pick up another one. So this is what the method detects. So again, we are transforming it to the sparse matrix, and let's predict this using our model. So now it's detected as 0. So 0 is our non-spam. So this is predicted as a regular message. So our model is able to do a decent job because if you will see the score of specificity and the accuracy score, different metrics are pretty good, and the ROC curve is also showing a good area under the curve, and it's hugging these two axes. So overall, if we look at the model again, so what we did is, if we go back quickly up, so what we did in this whole model is first we imported the data, and then after that what we did is we calculated the imbalance in the different classes. We have two classes, a class like the spam and the ham, and we mapped the non-spam as 0 and the spam as 1. And then what we did after that, we used the sklearn to split the data into test and train split, and then we used the count vectorizer to basically count the number of words in each of these sentences, and then we converted that into the sparse matrix. So basically what we did is we used the transform method to the count vectorized transform method to convert that into the sparse matrix, and after that we built the model, and then we fit the model, we predicted the classes, and then we evaluate the model. For evaluation, we calculated the accuracy score and the confusion matrix we built, and from the confusion matrix we actually calculated the sensitivity and specificity. And for our use case, we don't want any of the regular messages to be tagged as spam, so we used the specificity as our main actually metrics, because we want the specificity to be as high as possible. So that's what our main metrics, and we calculate other metrics also, precision and then recall and F1 score. And after that, we use the ROC curve for another metrics to see how our true positive and false positive rate vary when we vary the threshold. And then we calculated the ROC under the curve. And then after that, finally, we use some of the text messages or some sample data to see how our model is predicting for these two values, and it's predicted accurately. So that's all about this project. So I hope now you got a good learning about how the Naive Bayes multinomial model works. And similarly, you can use the binomial also. You need to just replace while building the model as binomial Naive Bayes. So this is all about this project, and it's a very interesting project to be added to your resume. And then please go through this video again and again to get a confidence how this model works, and also please write that by yourself. Don't just go through this video. In parallel, uh, start implementing this project also by yourself by writing the code. And if you like this video, then please hit the like button, and please subscribe to my channel, because it motivates me to make more and more such videos that will be helpful for your learning. And thanks for watching this video.